Yeah, today we are going to talk about hypothesis test. Here we have 3 steps. We have the null and then the alternative hypothesis, and then the second one we have the test statistic, and then the third one, which is the last one, is what the critical and the rejected region. Now here, our test statistic, we use the Z or the T distribution to find out, which is what our sample mean minus what populated mean all over the standard deviation over what root of what our n. So we are going to take examples and then we know more about how we can go about it. So here's an example. An electric firm manufactures light bulbs that have a lifetime that is approximately normally distributed with a mean of 800 hours and a standard deviation of 40 hours. If a random sample of 30 bulbs has an average life of 7, now we have our populated mean, which is what 800 hours. Now we have, so here our statistics test is what normally distributed. That means we are going to use what the Z test, which will give us this, and we know that our sample mean is what 788 minus what populated mean, which is what 800 all over our standard deviation, which is what 40 all over what population, which is what 30. So when you use your calculator to solve this, you are going to get what negative 1.64. So you can even try using your calculator. This is the value that you get. So our Z, that's the statistics test, is what negative 1.64. Now from here we are moving to what our critical or what our rejected region. Now to know our rejected or our critical region, we first have to find out our critical value, which is what the ZCV or CCV. That's what our critical value. Now what you have to do is that let's use the table to determine that. So this is the table. This is a normal distribution table, which is not drawn to scale here. We have the left tail and the right tail. Looking at this, is that because of the equal to not equal to, you have to use what it's supposed to be a two-tailed test. This is what a two-tailed test. It can be left-tailed or what right-tailed. Now when it's left-tailed, we have to what divide our level of significance by what 2. It will lead us to what the left tail, and then when we divide by 2 and we subtract it from 1, it will lead us to what the critical value at what the right tail. So let's try and solve that. Now our Z, our level of significance is what 0.02. exactly. Is 0. So when we divide 0.02 by 2, we are getting what 0.01. Now you have to locate 0.01 on the what Z. Now from the table we can see that 0.00990 is closer to what 0.01. So we are going to trace this. We are going to take what negative 2.3 and what 3. Are you getting it? So it's going to be negative 2.33. Now for the right part too, we can see that what 0.99013 is closer to what 0.990. So we are going to take what 2.3. We are tracing it what 3. Are you getting it? Here, so our critical value at the left side is what negative 2.33, and then at the right tail is what positive 2.33. So let's graph the values. So let's say our negative 2 is here, 0.33, let's say is here. So this is our critical value, and then so this become our what? Critical region for the left hand side. So the same for the right too. So this, let's say this is our 2.33. So this become our critical value. Now we have to check whether or not our statistic test falls within or out of the what? Critical region. So we are going to graph negative 1.64. So negative 1.64, our z that is what? Negative 1.64. So let's graph what? Negative 1.64. So our negative 1.64 will be somewhere here, which falls outside the critical region. So we are going to what? Accept the what? The claim that what? H, the null hypothesis is what? Is what? True. We are just going to accept it here. Are you getting it? So we are going to accept it. We are not going to reject it. In case it falls within the critical region, either at the left or at the right, we are going to what? Reject it. Yes.